Hi guys, in today's video we're going to look at what is benzene, Kekule's structure, problems with Kekule's structure, including benzene's resistance to addition reactions, the enthalpy of hydrogenation, and the bond length within benzene. And finally, we're going to look at an exam style question.
So what is benzene? Well, benzene is the simplest arene. It has a molecular formula of C6H6 and an empirical formula of CH. And what does benzene look like? Well, Kekule, a German chemist, proposed this model of benzene. He proposed that benzene was a 6-carbon ring with alternate double bonds. And you can see the structure he proposed right here. We have display formula and skeletal formula. You can see the 6 carbons forming a ring and these alternate carbon double bonds. However, there are a number of problems with Kekule's proposed structure. The first problem was that benzene does not react as expected. It's resistant to the typical addition reactions that we'd expect it to undergo if it had these alternate double carbon bonds. The enthalpy of hydrogenation of benzene is also not as expected. It's less exothermic than we'd expect. And in our benzene molecule, all bonds are the same length, which doesn't fit in with this theory of alternating double and single carbon bonds. So let's have a look at each of these problems individually and see what that can tell us about benzene's structure. So first of all, looking at benzene's reactions, we'd expect benzene to undergo electrophilic addition, just like alkenes do, and alkenes we know have double carbon-to-carbon bonds. However, benzene instead undergoes electrophilic substitution reactions. Now, Kekule tried to explain this by proposing this model here. He tried to explain it with a model showing a rapid dynamic equilibrium, where these alternate bonds shifted in place in this dynamic equilibrium and they changed position very, very fast. However, he was unable to explain the next two problems. The first of these problems was that the enthalpy of hydrogenation was less exothermic than we predicted. Now, hydrogenation is the addition of hydrogen to an unsaturated chemical, and we can actually predict the enthalpy of hydrogenation using bond enthalpies. So here we have the hydrogenation of cyclohexene, which is a 6-carbon ring with only one double bond.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.